sir. One minute. Hello? Is the PPT visible?
Yes, sir, we can see it, sir.
Yeah. Okay. Right. Sorry. Right. Now, last class, I think even though I have just started with this particular topic, okay, so there are some disturbances we could not able to communicate to you. Okay. Right. So from here, I will be starting again. Okay. Now, this is what is called as the hydraulic actuators. So this is the topic which I took after discussing about the different types of the valves. Okay. So just to recollect, three different types of the valves we have done. Okay, that is pressure control valves. Okay, or the pressure regulating valves, whatever it is, flow control valve and direction control valve. Okay, after we have completed the valves and its types, the next topic what we are moving through is the hydraulic actuators. Okay, right. Now these hydraulic actuators, as you know already, the actuators are nothing but the devices which are going to move with an external force or pressure. Okay. Now, accordingly, here hydraulic actuators or pneumatic actuators. Okay. They are going to use the pressurized oil or the compressed air for the purpose of actuation. Okay. The types are linear actuators and the rotary actuators. So that is two different types of hydraulic actuators or pneumatic actuator. One is the linear and rotary. Okay. Right. Is I am clear? Is I am voice is clear?
Yes, sir.
Okay, fine. Now, linear actuators are also called as what? Hydraulic cylinders or simply a cylinder. Okay, now you can clearly make it out. The basic difference between linear actuator and rotary actuator is the type of the motion. Okay, the motion is going to be linear, obviously in linear actuator, and the motion is going to be rotary in case of rotary actuators. Okay, but generally linear actuators we call it as the hydraulic cylinder, pneumatic cylinder, or just simply a cylinder. Okay, now the basic function, it's just like a piston cylinder arrangement. The piston is going to reciprocate in the cylinder, okay, due to the pressure. Now, depending upon how are you going to give the pressure, okay, depending upon how you are going to give the pressure, now we have further classified into single acting cylinder and double acting cylinder. Okay, right. Now, next is the single acting cylinder. Okay, now in case of single acting cylinder, basically Okay, right. Still there are only 10 people. Okay, right. Now, in case of your single acting cylinder, okay, single acting cylinder, the control pressure, okay, the control pressure is going to be applied onto what is called as the control pressure is applied onto one side of the piston. Okay, please understand this. The control pressure is applied onto one side of the piston. Means control pressure is nothing but what? The pressure which is required to move the piston from one end to other end. Okay, some force is required. Now, which is giving that force is the hydraulic oil, okay, or the oil or the air correspondingly in hydraulic and that of the pneumatic. Okay, now by which you are exerting a pressure on the piston to move. Now, the where how are you going to give is from only one side. That means the oil is going to be applied. The oil is going to be the supplied through one particular port. Okay, one particular port. Okay. Now here we are going to use two different terms. Okay, one is called as the extension. Okay, one is called as the extension. Okay, the other one is called as the retraction. Okay, the other one is called as the retraction. Okay, so extension and retraction. Okay, now extension is nothing but okay, now we call this as this point is called as the cap end, and this one is called as the rear end. Okay, right. So now the movement of the piston from this point to this point, okay, that is from cap end to the front end or the rear cap end to this, okay, is going to be called as your extension from one to another. And in the extension, the springs are going to be get compressed. Okay, during the extension, the springs are going to be gets compressed. Okay, and for the retraction, I need not to apply any force. Okay, I think you can understand. For the retraction of the piston back to this position, I need not to apply any force because the compressed spring is going to have a stored energy. That stored energy is going to be liberated. The stored energy will push the piston back to the initial position. Okay, now that is how the single acting cylinder is going to work. Therefore, only for the extension you require some pressure. Okay, for the retraction you need not to have any pressure because of the presence of the stored energy. It's going to be given back. Okay, that is called as extension and retraction. Okay, is it time clear? Is time clear, please?
Yes, sir.
Okay, right. Now that's about the extension and the retraction. Okay, right. Then next we'll try to understand how you can able to control these single acting cylinders. Okay, that is nothing but control of a single acting cylinder. Okay, now we have two different diagrams here. Okay, now accordingly, now if you observe, what is this? This diagram is about. Is it hydraulic case or a pneumatic case? Is it a hydraulic circuit or a pneumatic circuit? Have you come across with symbols of the symbols up till now in your FPS? Fluid power? Hello, dear students. Have you come across with the hydraulic symbols up till now in your fluid power? Yes or no, at least. Gankar? Subramania? Hmm? Hydraulic. Roshan?
Yes, sir.
No, is the symbols have been done? The hydraulic.
Yes, sir.
Okay, now what is this guy? If you observe, okay, right. Now Okay, right. Now, whatever we are going to observe here, okay, so this is going to be the symbol what we are going to use for the pneumatic circuit, okay, and this is the one what we are going to use for the pressure source, okay, right. Now, this is about the diagram of a control of a single acting cylinder. Now, in this case, the diagram, if you observe, we have one symbol here, okay, we have another two symbols which are going to be present in the valve actuation symbols, okay. So this valve actuation symbol is nothing but it is actuated by means of a solenoid. So this is nothing but your spring actuation. One is the spring actuation, other is the solenoid actuation. Okay, right. Now in this is the closed condition. Okay, you can understand. In this case, the closed condition. So now no current as such is passing through the solenoid. Okay, we are not passing any current through the solenoid. So now the spring is going to be like this. Okay, right. Now, what I will do is when I am going to pass the current to the solenoid, okay, when I am going to pass the current through the solenoid, due to the electromotive force, okay, due to the electromotive force, what is going to happen is the solenoid is going to attract the iron core, okay, and due to that attraction, okay, due to that attraction, the actuation is going to start. Okay, means what is going to happen? The shifting of from here to here, I am going to shift. Observe, you can observe. So this is the closed condition. So this is the open condition. When this block is going to come and sits here, the pressure source is going to be connected to this line. Okay, so to this pressure line, to this pressure line, the source is connected. Therefore, what is going to happen now? The hydraulic coil starts to move in this. The hydraulic coil starts to move in this. Okay, what it does? It pushes the piston onto the other side. That means what is going to happen now? You can observe the spring is going to compress. Okay, now the movement of the piston is going to be present till the time you are going to pass the current. Okay, till the time you are going to pass the current, the movement of the piston is going to be present. Okay, once you stop the current, okay, once you stop the current, what is going to happen is this will come here. Okay, so this will come here and leads to this particular diagram. Okay, what is going to happen now? At that moment, now this is going to spring it back. Then the movement is going to be from this point to this point. The movement is going to be from this point to this point. It is what is shown here. Okay, where you are sending to where? You are sending to the atmosphere. Okay, now this is what is the symbol here. Symbol for exhaust. Okay, you are venting. Okay, you are vent to the atmosphere. We use the word called as vent to the atmosphere. Okay, this is what is the actuation is going to occur. That is with respect to what? Sending the oil back to the atmosphere is happening because of what is called as the stored energy within the spring. Therefore, for the extension only, you require the current to be passed. For the extension, you need not to have any energy. The stored energy of the spring only is sufficient to give it back. Okay, so that is about the control of a single acting cylinder. Okay, right. Correspondingly, if we move further, now that's about a double acting cylinder. Okay, then in case of double acting cylinder, okay, so a case of a double acting cylinder wherein we'll be having what? Okay, yeah, a case of a double acting cylinder. Now in case of double acting cylinder, first of all, we'll not be having any spring. Okay, so sorry. Okay, first of all, we'll not be having any spring. That is very, very important. Okay, right. No spring is present. Now, when there is no spring, okay, now earlier spring was used for the purpose of retraction. Okay, means to send it back to the original position. So when there is no spring is going to be there, then how I could achieve the retraction is important. Therefore, when there is no spring, there is no question of the stored energy. Okay, energy is not stored. Therefore, you require one more actuation method for the purpose of sending it to the initial position. Okay, right. Now in the double acting cylinder, remember, very important, the term double acting cylinder is going to be used when the control pressure, okay, when the control pressure is going to be applied to both the sides of the piston. Please observe. Okay, the control pressure is applied to this port and also the control pressure is applied to this port. Okay, so both the ports you are going to apply the pressure. Assume if you are going to apply the same pressure, okay, what is going to happen? Here also I am going to apply the same pressure. Here also I am going to apply the same pressure. Okay, that means what? Piston is going to be stagnant. Okay, so piston is going to be stagnant because there will be equal forces acting from both the sides. Hence, there is no movement. Okay, therefore, what is responsible for the movement now is the responsible for the movement is what is called as the difference in the pressure. The difference in the pressure between the two sides, okay, is responsible for us to move the piston from one end to the other end or other end to that is extension or retraction is going to happen because of the difference in the cylinder. Let me just say P1 and P2. If P1 is greater than P2, then extension is going to occur. If P1 is greater than P2, then the piston is going to move from this end to this end. Okay, for P1, okay, P1 greater than P2. Okay, P1 greater than P2. Okay, once again, just put the charger. If P1 greater than P1 is greater than P2, the extension is going to occur. On the contrary, if P2 is going to be greater than P1, then what is going to happen? The movement is going to be from the other end to other end. Okay, right. Now this is the way that we are going to discuss about what is called as the extension and the retraction. Okay, right. Now that is what, okay, now this is going to occur, right? So this is going to occur, okay, this is going to occur whenever what is called as the pressure P2, okay, P2, okay, is going to be greater than P1. Okay, now depending upon what type of motion that you are going to give, you correspondingly you are going to plan with your application of the pressure. Okay, so that is a case of the double acting cylinder. Okay, so now these are the symbols that we are going to use. Okay, you can observe there are two lines. Okay, earlier if you observe, so we have only one line here, that is nothing but the application of the pressure, and spring you need to show, that is very important. Okay, but here the second one, there is no spring, but the application of the pressure is at two different ports. Okay, right. So this can also be used, or simply this line and a line, something like a T can also be used to represent the double acting cylinder. Okay. Now, similarly, we'll understand the control of the double acting cylinder. Okay. Now here, as we have mentioned, we'll not be having any spring like. Okay. Therefore, what you have to do now is, for passing the current, okay, now for making it to move from one point to another point, okay, then you have to apply the pressure. Okay, right. Now observe here. Now in this case, if you observe, right, now current is the control of a double acting cylinder with solenoid, not activated. Okay, right. Now in this case, now once you pass the current to the solenoid, let's say that if you pass this current to the solenoid here, okay, now one movement is going to occur, that is the movement, or let's say this one is going to shift. Okay, so this is going to shift here. Okay, so this fellow, okay, will come and connect to over here. Then the pressure source is going to be there. Then it moves to the other side. Okay, now the movement is going to be there till the time. The movement is going to be there till the time you are going to pass the current. And once you stop the current, okay, once you stop the current, means there is no movement. Okay, there is no movement. Then current to the other solenoid. You have stopped the current here and started to give a current to the other solenoid. Okay, so that will make the movement to be reversed. Okay, for one movement, for forward movement, pass the current to one solenoid, and for the reverse movement, pass the current to the other solenoid. Okay, right. Now in this case, if you observe, what type of cylinders that you need to choose here, that is very important. In case of your the hydraulic cylinder, the choice of cylinder is going to be very important. Okay, you know, force is equal to pressure is equal to force by area. Okay, so a force which is going to be required, okay, the force which is going to be required is equal to the pressure of the hydraulic oil that you are going to place, and also the area of the cylinder. Therefore, area of the cylinder is going to play a major role. Okay, so now the choice of the cylinder, okay, is going to be determined by the force required, okay, which is determined by the the force required to move the load, and also the force, and also what is the speed with which you want to move. Okay, that means, is it slowly you want to make the movement, make the movement of this the piston, or you want it to move faster. Okay, so all those things has to be taken care. Okay, right. So this is about the control of single acting and double acting cylinder. Okay, now here one thing that you need to observe here is the way that actuation is going to be done. Okay, now in this case, the actuation was done by using the spring, sorry, the solenoid. Okay, and reverse is by the spring. Correct. Forward is by the solenoid, reverse is by the spring. Similarly, I can remove this. Okay, I can remove the solenoid and I can use the various different actuation symbols. Okay, if you remember, sometime in a directional control valve, we have discussed various different symbols. That is push button, okay, push button, lever operated, cam operated, controlled pressure, okay, or leg operated. All those things we have observed. Okay, so you can have any different combination. You can remove this solenoid, or you can have pedal operated, or you can have push operated, or you can supply the pneumatic cylinder, pneumatic pressure. Anything is going to be possible. Okay, right. Now I just have small two videos which are going to be there for the quick understanding of this what is called as the single acting cylinder and the double acting cylinder. Okay, right. So just let me take that, show that for you. Okay.
Growing businesses need a hosting solution that is powerful yet easy to manage. Let's look at how business host.
Can you able to see the thing?
In this video,
Yes, sir.
to operate single acting
Please
cylinder
listen.
using 3x2 direction control valve. So let us first draw.
Okay, please listen. Okay, so just a 2 minute, 3 minutes video. Okay, please observe the hydraulic symbols also. Okay, and how the single acting cylinder is going to be done, and what is the actuation which has been taken care of. Please observe. We have a small question after this. Okay. Right.
Draw the circuit, and then we'll try to understand how the circuit works. So various components are shown over here. So as you can see over here, this is the reservoir, then filter, the pump which is driven by the motor, then shut-off valve or shutter valve, pressure gauge which indicates the design pressure in the circuit. Then this is the pressure relief valve, which is normally closed valve. If the pressure exceeds the design pressure, then only this will open, and the fluid will be again, it will be going back to the reservoir. Then this is the pump port or pressure port P, reservoir port R, and the cylinder port A. This is a single acting cylinder. The fluid will be admitted only on one side of the piston, and therefore it is known as the single acting cylinder. Now this is lever operated. So this is the symbol for lever operated spring control, 3x2 direction control valve. So there are three ways, P, A, and R, and there are two positions. So this is left envelope mode and this is right envelope mode. So let us see how this particular circuit works. So for the left envelope mode, the fluid will be entering from the reservoir through the filter, pump, then pump port P to A, and from A it will cause the piston to extend and compressing the spring. So the retraction of this particular piston will be due to the spring force. So that will be when we are in the right envelope mode. So let us see what will be the operation in the right envelope mode. So as you can see over here in this particular right envelope mode, the port P is blocked and port A is connected to the reservoir, that is R. So when we operate the lever in such a way that we'll get this right envelope mode, then at that time, due to the spring force, the piston and piston rod will retract and the fluid from the other side will be going through A to the reservoir R. So in this way, we can use this single acting cylinder, operation of the single acting cylinder using 3x2 direction control valve. Now let us see the actual circuit animation over here. So when we are in the left envelope mode, then you can see there is an extension of the piston. And when we are in the right envelope mode, then due to the spring force, there will be retraction of the piston and the fluid will go to the reservoir. So in this way, this particular circuit works.
We see it happen everywhere, at any time. 70. Good grammar and spelling are important, but if you want to write essays that inspire.
In this video, we'll try to understand how to operate single acting cylinder using. So as you can see over here, this is the.
Okay. And you can able to make it out. Okay, now this diagram, okay, now where I have stopped, can able to listen here to me? Right? Have you observed the video?
Yes, sir.
Okay, right. Now what is this actually? This one? What is this one actually? Can you able to see? Can you see the mouse? Can you see the movement of the mouse?
Yes, sir.
Yeah, what is this actually? This one? What is this?
It's a controller.
Yeah. What is this called?
Lever operated.
Okay, so this is a lever operated spring controlled. Okay, now the whole setup, okay, whatever we are observing here, the whole setup is called as your lever operated spring controlled. 3/2 he says. Okay, 3/2 I think he has given told. Okay, I'm just making it again. So 3 is number of the port. Okay, so it is 1, 2, and 3. 3 ports and 2 positions. Okay, 1 square, 1 position, another square, second position, 2 position. Okay, now all this we have discussed in the beginning stage. That is the components. If you remember, the first slide that we have discussed was the components of hydraulic system. Okay, that is what we have: a reservoir, then we have a filter, then the pump is going to be there. The pump is going to be driven by the motor. So this is a symbol what we used for the pump. Okay, then shut off valve. Okay, now you can make it to the operate, and the pressure gauge. So this is what is the symbol for PRV. PRV is pressure regulating valve, or the pressure reducing valve. Okay, it acts as a safety device. Okay, right. Now once you have shown, now the pressure is going to be there. Okay, so this movement is going to occur onto the other side. Okay, that is what he has shown in the list case. Okay, that is at the end, if you remember.
Single acting cylinder, operation of the single acting cylinder using the lever ends arm. Right.
Yeah.
So when we are in the left envelope.
Now this you can observe here. Okay, now this is what is that he is showing. Okay, in this case, what is going to happen is, now this will connect. Okay, this will connect here, and now just observe. Yeah. Okay, now the switching has occurred. If you observe, previous switching was not there. Now here switching has occurred. Due to the switching, what has happened? Now you are just pumping. Okay, and the flow is going to happening here. Okay, so this flow is going to be there till it goes to the other end. Okay, right. Next.
You can see,
yeah,
there is an extension of the piston.
Okay, extension is happening now.
And when we are in the right envelope mode.
Yeah, now, okay, now again, if it switches back, now this will come back to the left. So where it is going? Okay, it is going back to where? So it is coming and going back to this sum. Okay, so that is what he mentioned. Okay, so this is about the single acting cylinder. Okay, so the working of a single acting cylinder. Okay, so similarly, okay, just for the better explanation, I am just bringing these figures here. Okay, so similarly, we shall have the working of the double acting cylinder. Okay, so in case of double acting cylinder, okay, yeah, so in case of yeah, please listen.
Cylinder using 4x3 direction control valve. So we have drawn this particular circuit for operating double acting cylinder using this 4x3 direction control valve. So as you can see over here, we have shown the various components of this circuit. So this is the reservoir, then filter, the pump which is driven by the motor, shut off or shuttle valve, then this is the pressure gauge. Now this particular valve is 4-way 3-position direction control valve or 4x3 direction control valve. So this 4-way stand for P, A, B and R, whereas these 3 position they stand for left envelope mode, center position and then the right envelope mode. This is the double acting cylinder in which the fluid is admitted on both the sides of the piston. The pressure relief valve is used to relieve the hydraulic circuit when the system pressure exceeds the design pressure. Then pressure gauge will indicate, it will sense the pressure and will indicate the pressure inside the circuit. For the given particular position, the port P is connected to the port R. So the fluid will enter from pump into port P and will directly go to the reservoir port R and no operation will be performed. Now let us see what will happen when we operate the. So this is a symbol for lever operated and spring centered or spring controlled direction control valve. When we operate the lever in such a way that it will be in the left envelope mode, then what will happen? And we'll operate this particular lever in such a way that it will be in the right envelope mode, then what will happen? That we will see in the next animation. So let us first draw this particular circuit again over here, indicating that we are in the left envelope mode.
So this is the first switching position.
So as you can see over here, on the pump port or pressure port P, the fluid will enter into the cylinder port A and the fluid will be admitted on this side of the piston. Now this will cause the extension of this particular piston and the fluid from the other side, that is other port B, will enter into the reservoir port R. Now let us see what will happen when we are in the right envelope mode. So at that time, the fluid from the port B, it will enter into port B and then it will cause the retraction of this particular piston. So in this way, we can operate this particular double acting cylinder using 4x3 direction control valve.
Germs and oil attack your skin constantly. Want to fight the pimples? Then why are we so? Switch to Garnier Men Actified Face Wash. It fights up to 99.9% pimple-causing germs and gives you pimple-free clear skin every time. Garnier Men Actified Face Wash.
The table looks nice, huh?
Choice kiski hai?
Yeah.
In this video, I explain design of hydraulic circuit. And in a hydraulic circuit, SAC means single acting cylinder is used as actuators, and this single acting cylinder is operated by using the 3x2 DCV. DCV means direct.
Okay, so great. Okay, so that's about the working of a double acting cylinder. Okay, right now. Once again.
This video explains operating double acting cylinder, particular R, whereas these 3 positions they stand for left envelope mode, center position, and then the right.
Yeah. Okay. Now you can observe. Okay. So there is a movement from this to this, and on the other side, okay, is happening because of the case, right? Now he has shown how the switching is going to occur from both the sides. Okay.
For the given particular position,
I'm just pushing across.
Entered or spring the next animation. So let us first draw this particular circuit again over here, indicating that we are in the left envelope mode.
Yeah. So this is the first position. Okay.
So as you can see over here, on the pump port or pressure port P, the fluid will enter into the cylinder port A. Now this will cause the extension of this particular reservoir port R when we are in the right envelope mode.
Yeah.
So at that time, the fluid from the port P, it will enter into port B, and then it will cause the retraction of this particular piston. So in this way, we can operate this particular double acting cylinder using 4x3 direction control valve.
Yeah. Okay. So this is just to
What does?
Yeah. Okay. So to give a brief intro about how the single acting cylinder and the double acting cylinder is going to work as such. Okay. Right. Now after this, we'll have another two types of cylinder. So even though we have single acting and double acting, we have another two simple cylinders which are going to be there. This is called as tandem cylinder. Okay. Now quickly we just go with this tandem cylinder. So what do you mean by tandem cylinder is important. Okay. Now this tandem cylinder is going to be required whenever it is expected that more amount of force is to be developed. Okay, if it is required for us to develop larger amount of the force, now what we have is we will have two different cylinders one by the other. Okay, now here currently what we have is we have only one cylinder. Okay, now if you observe, we have only one cylinder. Okay, and one piston which is moving across. Okay, right. Now in tandem cylinder, basically, now we are going to mount two cylinders in line with a common rod. Okay, now this is what is the requirement. It is higher forces can be developed. Higher forces can be developed for a given pressure. Okay, so for a given pressure of oil and bore size by mounting two cylinders in line. Now here pressure remains same for a given pressure and the same bore size. Okay, now what I am having is the bore size is same. I don't have any requirement for, or it's not possible for me to have the higher diameter or a lesser diameter with the same bore size. Now how I can able to have the larger amount of the force? Okay, that is by having two different cylinders. Okay, in line. Okay, remember mounting two cylinders in line with a common rod as shown in the figure. Now here just observe a tandem cylinder is used in application where a large amount of force is required from a small diameter cylinder. Pressure is applied to both the pistons, resulting in increased force because of the larger area. The drawback is that these cylinders must be longer than a standard cylinder, okay, to achieve an equal speed because flow must go to both the pistons. Okay, now you can just observe here. Okay, now we have two different pistons. Observe two different pistons. Now, if in the absence of the right one, okay, so only one piston giving the motion, correct? Only one piston giving the motion. The amount of force generated is obviously lesser. Okay, therefore here, in order to come out with that, what we have done is we have two cylinders in line. Two cylinders are there. Two pistons are going to be there. So both the pistons, I am going to apply the amount of force. When I apply the amount of force for both the pistons, okay, the amount of force which is going to be generated is going to be more for the same amount of the bore size. Now here, remember, bore size is same. The bore size is same, and the only the important thing here is we have the two different cylinders. Okay, so which are moving. Okay, so now you can have another cylinder, but the time required and the force you can able to have, but the disadvantage is that you need to have a lengthier cylinder. You need to have a more lengthier cylinder in order to execute this particular strategy of getting a more amount of force. Okay, this is about a tandem cylinder. Okay, right. Then another extension is what is called as telescopic cylinder. Okay, so this telescopic cylinder is a case of single acting cylinder. Telescope. Okay, so it is like you can observe. Okay, so just extending the portion. Okay, now if you can remember, okay, right, it consists of a series of nested tubular segments. Okay, some tubes are going to be there, larger tube, then smaller tube, then some still smaller tube, still smaller tube. Okay, if I just push everything, it will come to a small box. Then you can able to retrieve. Okay, now I think you can able to understand with more amount of the diameters. Okay, with the varying diameter, I can push everything into a single piece. And if I'm going to pull it out, okay, if I'm going to pull it out, all those will come to that particular length. That means we call each of them as a sleeve. Okay, we call each of them as a sleeve. Right? I'll show here. Now look here. So this is one position. I think you can able to understand. So you have so many different cylinders which are going to be there here, which you have pushed it. Okay, now I am extending. Okay, when I am going to extend, so now 1, 2, 3 cylinders. Now here, still if I'm going to extend, now you can observe here. Okay, please observe this. Okay, there is already one. Now you can observe the ashing here. Okay, so means the cylinders are pressed. Okay, pressed in a sense have been inserted. Okay, now I have pulled. Okay, once I have pulled, I have got one more. Now this is completely I have pulled everything. Therefore, 1, 2, 3, 4. 4 cylinders are going to be there here. Okay, that means what? I can have, I'll call these cylinders as what are called as the sleeves. Okay, so this is what is called as a telescopic cylinder. The advantage of this is you can have a longer working stroke. Okay, so the working stroke is going to be from this point till this point. Okay, because of the number of sleeves. More number of sleeves, like here 4 sleeves, will gives you more amount of the stroke length. Okay, by which you can have a more amount of force that can be able to make. That is another type of single acting cylinder is telescopic cylinder. It consists of a series of nested tubular segment. This is what is that I am mentioning. Nested tubular segment called as the sleeves. Okay, so these sleeves work together and provides a longer working stroke than possible with a standard cylinder. If I say, once I say a standard cylinder, it is nothing but one piece of cylinder with one diameter and one piston in it. Okay, but here I have the various different cylinder combination. Okay, that is 4 to sleeves can be used. Okay, so now you can, the smallest sleeve is going to be the one which is going to be judged to get the maximum force. Okay, right. So these are all the different types of hydraulic cylinders which are going to be there. Okay, so this is the figure. So next class we'll go with the rotary actuators. Okay, now as of now what we have done is, okay, we have started with hydraulic actuators. Okay, so under hydraulic actuators we have discussed the linear actuators. Okay, linear actuators are nothing but your hydraulic cylinder or simply a cylinder. Okay, right. The various types of hydraulic cylinder or linear actuators are going to be a single acting cylinder and double acting cylinder. In single acting cylinder, the pressure you are going to apply on one side of the piston. Okay, and for the movement is going to be, you are going to apply the pressure. For the reverse direction, for the retraction, the spring is going to push it back. Okay, right. But on the contrary, in the double acting cylinder, so the fluid pressure is going to be applied on both the sides of the piston, and hence the difference in the pressure is responsible for the extension and also retraction. Okay, and we observed how this control of single acting cylinder is going to happen in this particular slide with the presence of the solenoid and the spring. Okay, and the control of double acting cylinder we have observed again in the presence of 2 different solenoids. Okay, right. Then we observed 2 different the videos wherein he has used the lever operated mechanism for the purpose of the actuation in both single acting and also in the double acting cylinders. Okay, right. Then an extension of this is what is a tandem cylinder. I want more amount of force, therefore I need more amount of cylinders. Okay, so I will keep cylinders one after the other, means mounted on the same line, right, and with 2 different pistons. So you need to apply the pressure on both the pistons. Okay, both the piston, by which you will get an increased force. But the problem is you need the more amount of space to have those different accommodate more number of cylinders. Okay, then one more thing is we have telescopic cylinder, that is a nested cylinders. Okay, now you have a nest of 3 or 4, so those are going to be called as the sleeves. Okay, once the sleeves are going to go one inside the other, once you apply the pressure, slowly the sleeve starts to expand. Because sleeve starts to expand, and because of that number of sleeves, that number of expansion is going to be there, by which your movement of the oil is going to be more, and the working length, okay, or the working stroke rather you call it as, is also going to be longer. Okay, so these are the telescopic these are the different possibilities of the linear actuators. Okay, so next class we'll start with what is called as the rotary actuators. So I think we'll stop at this time. Okay, we'll take the attendance. Okay. Yeah, Abdul Khalik Pasha. Please answer attendance. Abdul Khalik Pasha. Alok. Anil Kumar Master.
Sir, present, sir.
Ankesh Aman.
Yes, sir.
Ankesh, yeah. Okay. Basuraj. Basuraj. Chandan
Yes, sir,
KM.
present.
Yeah.
Present, sir.
Yes, sir.
Chetan Kumar DK.
Present, sir.
Okay. Dheeraj.
Yes, sir.
Himanka. Himanka. Murali Kishan. Kunal. Kunal. Dhanush. M. Dhanush. Junaid. Kunal present.
Kunal present,
Yeah,
sir.
yeah, yeah. Okay.
Kunal present.
Okay. Junaid. Shri Prasad. Niharika.
Present, sir.
Nihar. Nihar.
Yes, sir.
Nilesh. Nirab.
Yes, sir.
Rajwal R. Patil.
Present, sir.
Prince.
Present, sir.
Rishabh.
Present, sir.
Rohan.
Present, sir.
Roshan.
Yes, sir.
Sagar.
Present, sir.
Sharanaya. Sharanaya. Sheikh.
Present, sir.
Yeah. Tobit.
Present, sir.
Siddharth Shankar. Siddharth Shankar. Siddharth Sridhar. Subramanya.
Present, sir.
Sumuk. Sumuk. Ulas.
Present, sir.
Vivian.
Present, sir.
Pawan.
Present, sir.
Shivakrishna. Shivakrishna. Ranveer.
Present, sir.
Ranveer. Dhanush.
Sir, present, sir.
Gautam Sai. Chanakya. Simika.
Present, sir.
Shiv Pawan. Yeah. Okay, right. So we shall close the class. We'll meet tomorrow for the rotary actuators. Okay, thank you.
32 is present.
Who?
32, Nihar, sir.
Nihar, yeah. Nihar, you are present.
Okay, thank you, sir.